Hello, good evening, how are you doing? This is 8 till late live from youtube.com/Wi-Fi sheep with me, Tom. I'm only 8 minutes late on the stream tonight. I needed a cup of tea before we started. So, yeah, I thought if I don't get a cup of tea, I'm not going live. So, there we go. Anyway, great to have you company. How are you? Tonight we're carrying on from pretty much where we left off last week. Last week was a bit of an unannounced test stream, and to be honest with you, it went really, really well. And I thought, yeah, we'll try and do this as a kind of regular thing. I don't know if it's going to be every week, but we'll see. Saturday about 8 o'clock BST in the evening here in the UK is about a sort of good time, especially if we're getting into kind of the autumn, fall, winter now, so the nights are drawing in. Saying that, beautiful evening out there. So, yeah. Right then, so I'll bring you up to speed on the project shortly. Obviously, being live, anyone wants to chime in on the chat, and I can see that Philo B, something like that. I'm terrible with names, as you know from the previous live streams. Hello, good evening to you. I've enjoyed the Tiny Basic Computer says, well, thank you. A lot of people have, and yeah, thank you. I'm pleased someone gets something out of that. I'll try to pay attention to this cast. I watching this in conjunction with putting the toddler to bed. Fair enough. Well, best of luck putting the toddler to bed. It's all I can say. We've got a puppy, and that's bad enough. But yeah, if you want to drop a comment or ask a question or anything, doesn't have to be about Tiny Basic or what we're going to do tonight, but anything tech related with the channel or whatever, or just want to drop in and say hi, obviously that's great. You're more than welcome to. You do need to be a subscriber to the channel. Don't have to be a member or anything, just a subscriber, and I will try and get to all of those this evening through the evening, and sort of answer any questions or anything you've got. Right then, without further ado, and before we go any further, do you have a need for reliable and cost-effective web hosting for your blog, business or personal website? If so, then look no further than Cheap Host UK. Cheap Host UK's basic plan starts from only 58p per month. That's £6.99 a year. And if you're needing a little bit more, Cheap Host UK's premium packages start from £1.41 per month or £16.99 a year, complete with a free .co.uk domain. New customers can also take advantage of an extra 10% discount when purchasing any first-time hosting package or domain name from Cheap Host UK. Use discount code SHEEP, that's SHEEP, to get an extra 10% off. For reliable, cost-effective web hosting and domains, look no further than Cheap Host UK. Full details and an affiliate link are in the description to this video. Yep, so for your web hosting and domain name needs and solutions, Cheap Host UK, a sponsor here on Wi-Fi Sheep, 10% off when purchasing any product with discount code SHEEP, that's SHEEP, as you've just seen, and links to that are in the description. Just want to say hello to Findus, that's joined us from Denmark. I have just replied in the text chat there, but hello, welcome, thanks for joining us, good evening to you. Right, so the Tiny Basic build. This is the prototype build, so it's a little bit different to the new series for what we're going to be calling Project Rio, which the video is due this month really shortly. I know I keep saying, oh, it's coming out, it's due, just hang on, it'll be coming. It is. It's just trying to get around to doing it and catching up with all the other projects that I need to do here on the channel. That's why having this sort of live session, if you like, at least once a week is a good way to just kind of get through some of the project. So this one is the prototype of sort of the build I'm doing. It's a little bit different to the build I'm going to show you how to do step by step, but we kind of get to the same result, if you know what I mean. And obviously we're building this in a sort of a view to doing a production kit product at a later date. But obviously this is the kind of prototyping, which is normally done in secret, and I'm doing it very publicly. So just basically for you to enjoy and sort of see, you know, what I'm doing, and I guess make suggestions or see how not to do things more likely along the way. Right, so last week we left off with getting the prototype to work, because it wasn't working that well, but it was in a terrible 3D printed shell that it didn't fit in very well, so we broke that up and you know, got the thing working. Since then, what I have done is I've taken the serial chip out because I don't intend to use it on the Atmega 328p TV serial that we were using. So I've also done a rewire to rewire the main serial through from, there's multiple UART serials on a Arduino Mega 2560. Basically I had TX or UART 0 and UART 1 in use. I've now rewired everything, so it's just using UART 0, which is the main serial feed, and that means I've been able to update to the latest version of Project Rio TinyBASIC, because this prototype wasn't running it originally. So I've decided to keep everything and not scrap it, so I want to basically repackage and carry on with the development on this particular unit. So we needed a new case, so I needed a better casing solution, and that's where I did a little bit of work earlier in the week, and I'm just going to show you a piece of VT. Now, if you've been a Patreon or YouTube channel backer, you'll have seen this piece of VT pre-record that I shared earlier in the day. Before we go, let's just, or we roll that rather, let's just, where are we? Let's just say hello to channel members. So there are the current YouTube and Patreon channel members. Huge thank you to these people. These are brilliant people who, you know, back this channel for as little as £1, $1 a month, and it really is appreciated. We need to say a warm welcome to Mark Sterling and Paul Chiara. I don't know why I try and do names. I'm terrible at them. But they've joined us. Now, Mark, I don't know if I know Mark personally, but he is a name and someone who comments quite a lot on the channel. He's a big supporter. And it's sort of, you know, it's people that you get to know on and off. People like Lee. Lee is a big supporter over on Patreon. Comments on a lot of the posts and things to the members on Patreon. The Imp64 is a member, someone I actually do know from the RISC-OS Acorn community, and he is a channel member as well. And Anthony Bartram down the bottom there, I do know personally, again from the RISC-OS world. And who else? George. George also comments quite a lot, or likes a lot of the comments over on Patreon. So yeah, it's really good to have you on board, and thank you all so much once again. Over on Patreon, if you want to support me, you can go over to Patreon. It's patreon.com/Wi-Fi Sheep. Alternatively, you can support me directly here on YouTube with the YouTube membership scheme. They are the current prices in £. Prices will vary if you're outside the UK with your local currency. Okay, so let's roll this little bit of VT, and I'll show you kind of the process of where we are right now. And once we've done that, we'll come back and then we can work on it live. Just if I start doing stuff now, it won't make sense because you'll be like, where's all this stuff come from? So let me show you this, and I'll be right back with you live in a few minutes. So casing solutions, this is what I've got. This is an off-the-shelf ITX standard metal chassis PC case, which came relatively cheaply from China. Not expensive. In fact, the shipping to get it over here from China is more expensive than the actual product, which is often the way. So, take the bag off. So yeah, this is one of these, what they call the mini PC cases. That comes with 2 USB power supply. That's pretty standard affair, really. So let's grab a crosshead screwdriver. The advantage with these is that, you know, it's a metal case, and there's no way I could produce anything to this sort of quality at this kind of price. So this makes a perfect framework, if you like, for Project Rio prototype system. And inside, well, it already looks like there's a Project Rio in there. I'll be honest with you, I've been test fitting a few things off camera prior to shooting, so it's not like this is, well, it is brand new, but it's been opened and checked for size, and I just left some parts inside. But what is actually cool is that some features like the power LED and the button and even the USB will be able to be plumbed into the architecture we're going to put inside. So that's actually really quite useful. You can also get a bag of bits, which again, quite cool. Probably should be putting, got some extra, you've got mount screws for PCBs and stuff, which is potentially kind of useful. So probably need to think about decoupling this out actually. Where are we? There we go. So yeah, that's what you get. You get this sort of, well, it's standard pin connector type stuff that we can tap, which would be fantastic. So what I was thinking of doing is to try and customize this a little bit. I was thinking I might spray a textured stone type paint onto this bezel. I may have to cut into this, but because I'm running out of warm weather to be spraying things in, I kind of need to do it now. So I thought maybe stone texture for this. It is textured, but I thought I might retexture it. But then I thought this plastic bezel around here might actually do that in yellow, just to do something a little bit different, to brighten up quite a dull case. So screws in there have already been taken out. So it's just got four plastic tabs that you push in. And that should pop the front bezel off for us. Yeah. And do the other side. Okay. So it's actually only the front bezel I want, which is this. And you can see there is the two USB ports, and then there's the switch, and there's some LEDs for power and hard drive interface. So we need to take these out. Again, it all comes apart relatively easily. There's nothing in these that's particularly tricky, which is a relief. There we go, that's one of the little boards out. That's our USB ports out. And then basically there's this sort of, there's tape around the plastic, which we'll just take off. There we go, and I want to just, if we can get this power switch out without breaking it. It'd be good if we could. Should be able to lift off these lugs or something and pull it through. Oh, that's not good. Well, it's off. Unfortunately, that broke. Ah, damn it. And the other piece is shot off somewhere. Well, hopefully, with the button in, that'll be okay still. If not, we can always tack a little bit of something on there. Oh, that's annoying. Very brittle, that. Very brittle. You'd think that was a bit more flexible than it was. Oh well. There we go. That's out. Right, so that's the bezel we want. Now what I'm going to do, because I'm going to spray paint this shortly, I just got some everyday multi-purpose wipes. These aren't baby wipes, these are surface wipes. And I just want to clean, I want to clean any adhesive that was off inside that plastic, and also because this has been exposed on the front, just to give this surface a good clean. So we can get a relatively good finish on the paint. Something like that. And then I'll just go and get some towel or something just to dry that off. And then I think we should go and see if we can get this spray painted. Right, welcome to the garage, and I had a realisation that I don't have any working lights in here because the light circuit in here doesn't work for whatever reason, and I can't remember what it is. But so yeah, it's like late August, end of the day, so it's a bit dim. Apologies for that, but it should be good enough what we need. So spray painting, first things first. I know post-COVID we all hate wearing masks, but it's spray paint. Need to put some kind of respirator protection on. This probably isn't going to do it, but it's better than nothing. So just put that on, like that. Oh, God. Yeah. She's alright. So before we get started, I've got a couple of test pieces of PLAs. I've got the old case that we broke apart on the live stream, and I've got a piece of plastic from an earlier design, similar design but earlier design. So it's all printed PLA, but she's all scrap, so we'll use that. Now I want to test yellow, and this is the stone pattern stuff which I want to test. So yellow acrylic I've had for a little while.
I can't go to Asda.
Right.
Because they don't accept MasterCard.
No, you need a Visa.
Exactly.
Yeah. Sainsbury's might be okay.
Pardon?
Sainsbury's might be okay.
What may be okay?
Sainsbury's.
Yes, they are.
Yeah.
They are. Yes, that's why I said, well, I'll go to Sainsbury's.
Yeah.
Okay, bye.
Alright. Sorry about that. Right. So we'll do a bit of test just on the blue. It's been very, very watery. That's better. Yeah, that's okay. It's not bad. I can even hear this one rattling actually. So let's see what this one does. Let me actually get into it. It's actually spraying it. That looks absolutely terrible, as if like the paint's actually just spraying bits out and not actually spraying in. Hello, there you go. I'll be brutally honest, I'm not very convinced about that one. Yeah. It looks awful. So the yellow seems alright. Okay then. The first coat, which is just going a bit of yellow. That's not too bad. So the idea is we're going to let that dry, and then I'll mask off the yellow, and then the plan was to sort of try looking at doing this texture paint, but I don't know. I'm not too, I don't know, we'll see. It's very textured, which is more than I thought it was going to be. I thought it was going to be a bit finer than that. But I mean, it's interesting, but I don't know if I like it. And that's me being honest. But let's see. Let's let these things dry. We'll come back and then we'll see what they do. So if you're just joining us and wondering what on earth was that, that was a pre-recorded piece of VT footage, basically showing what I'd been doing with our Project Rio TinyBASIC computer prototype in preparing a new case earlier in the week. Obviously, that sort of thing wasn't going to work in live stream because, you know, I can't sort of go to the garage and spray paint things and have all the bits ready for tonight. So that's basically what that was. So if you stuck through that, thank you very much. Hello, we're now back. This is live real time. I'm Tom and welcome to 8 till 8 from Wi-Fi Sheep with a cup of tea. So I did take a photograph of the piece actually a couple of hours later, all taped up ready for the attempted spraying of the sort of pebble rock texture paint. Unfortunately, can I find the photo? Nope, and I haven't been able to get it loaded up on the live stream to show you right now. So let's, do you want to see the result? I guess that might be an idea. So here is the ITX metal chassis case. Again, really nice cases. And as I said in the pre-record, you know, I can't make anything like that at the price I bought this. And that's a really good sturdy case that we're using as a basis to mount the TinyBASIC Computer Project Rio system in. So the fascia, what's that look like? Are you ready? Here it is. Now I'm going to be brutally honest and say that the yellow needs another coat. You can see it's kind of patchy and blotchy in places, but overall I'm quite pleased with that. And I was really not feeling the texture paint. I had this idea that I kind of wanted. It's hard to describe it really, but sort of computers with kind of, you know, textured stone. We've moved away from all that, and I really wanted to kind of, you know, almost a clash. So you've got the black. I'm talking about aesthetics now, but these are important to me, especially as these are potentially going to be showcase pieces. So, you know, you've got the black matte of the chassis itself, and I just thought, you know, we've got the bright yellow or bright sort of highlight colour, and then I thought just something just different on the front, and that kind of stone texture. It's actually turned out really, really well. So I'm actually quite pleased with that. So what we're going to do now then is look at doing a reassembly and start seeing about how we might be able to mount parts inside this case. Before we do that, quick show and tell. I've got one or two tiny new bits that are related that I could show you quickly. So I've been buying again. Online marketplaces, especially things like AliExpress, eBay, are terrible, especially in the middle of the night. You thought, oh, I'll have one of those and one of those and one of those, and you just keep buying things. So let's show you a few things I've been buying. So this came in the letterbox today, and it's another brand new clone at Mega 328p. No, Mega 2560, which is the at the moment is the architecture that we're using for Project Rio. So these are Arduino. Well, this is a clone. It's Arduino AVR 8-bit single core RISC architecture. These they're running 16 megahertz clock speed, and they have 8K of RAM on board and 4K of EEPROM flash space, which for us has been absolutely perfect. So I bought another one because it's amazing how, you know, I get through these quite quickly. So that's that. Coming yesterday. Anyone know what that is? It's not RGB. It's a D sub connector, and it's DB9, which is the Atari joystick standard. and I should have got it out and I didn't. I knew I'd forgotten to prep something, but I got hold of a clone, very cheap clone NES controller for one of the Chinese clone systems. But instead of having the Nintendo end, it has the Atari plug end, or the DB9 plug. And one of the features of this case is, I'll show you in the back here, it has a panel which you can push out, which I have done. And that's meant to be for VGA, but obviously it's a D substandard. So you could actually put a joystick port in the back of the system. It's my intention to have a joystick that you can plug in to the TinyBASIC Project Rio system, and it will have it won't have the drivers, but you'll be able to write very simple drivers, or I'll provide code, very simple code, to be able to drive and read a joystick. So you'll actually be able to control games and graphics on screen just from an Atari standard pin-out joystick. It's not the greatest standard in the world, but I think it's good enough for what we need. So I bought one of these, and I do want to try and fit that in there as part of the case. So just quickly then, I went to a charity shop the other day, or thrift store, I think you call them in the States, and I picked up that, which is a Nintendo Wii cable, so it's composite, and I believe that connector is the same for N64 and GameCube. And as I don't have many of these sort of Nintendo peripheral cables, 50 pence, half a pound, 50 pence that was. You can actually see some, I don't know if that's dirt or if that's sun damage, UV damage, but it's discoloured just there, but it doesn't matter. I'm sure that's fine. So I picked up that cable, which I just dumped on there, and also they had this cable, which is just the standard RCA audio video jack cable. And again, you know, I seem to be the only one using composite cables, but it's there, it's useful. So we might use that one in a minute if we need to boot the system up. Anyway, right, so that was exciting. Let's look back at the bezel. So what I want to do now is I want to refit the parts that I took out that you saw. For those of you that were with us a little earlier, saw in the pre-record VT piece. So it actually goes together really easily. Unfortunately, as you saw, I did break the power switch, which I'm hoping isn't going to be hypercritical. But let's put the stuff back together. So it goes together really well. So this is the, make sure I've got the screws. So this is the USB. So it's two USB ports, and it's just connected to this pin connector, pin header. So we can tap that off our project, which would be fantastic. In fact, I might need to get the soldering stuff out, which I haven't prepped either, because we may end up building some bits tonight for what I've got planned. So we may need to go for a short break shortly, so I can set up soldering irons and things. Why is it the more prepared I try and be for these live streams, the sort of more chaos and the less prepared I am? I don't know why that is. Anyway, so let's put that back in. It's actually really nice that this stuff came apart relatively easily. I think it only had like multiple screw holders, but it's only got one. Wasn't even that hole, it was that hole. Okay. And my screwdriver is right next to me. Sometimes when you can't even see the tools in front of you. Just make sure that goes in straight. I don't want to over tighten things because this stuff's all got to come back out again when I go and do a respray of yellow. I should have known really, because yellow is an awkward colour, especially if you're spraying it on black. You need to prime it first really with like a grey or white, or it needs multiple coats, which you could argue I should have done. I'm just a bit worried actually about damaging that paint, so you might just do that on some foam packing. Screws in. Yeah, that's great. Now, power switch, which we're not going to use as the power switch, and I'll explain why in a minute. But I need to just see if I can get that to sit. So it did have another piece in here which is broke, but it pushes down, and then this sort of plastic tab here pushes. If I show you this board, it's 2 LEDs, and it's just a simple PCB button, and that's the button. And then you've got the LEDs and the power logic, if you like, on, again, pin-headed, that we can interface very easily with the build. So although these are designed for mini PCs, you know, this works really, really well as far as I'm concerned. So let's have a look. That goes, kind of goes like that, doesn't it? And it slots in. Yeah, that power button seems all right. And I'm guessing these, say guessing, I don't remember how I took this apart, but maybe I'm just going like that. And they just clamp down on the sides to stop the board sliding out. So I do have another one of these ITX cases, and they're not very expensive. I think about £12 or something. Ironically, it costs more in shipping. It costs about the same, if not more, to get them shipped. So by the time you've done that and paid the tax, you're probably just shy of £30. But, you know, they work for the moment, and there's plenty of very similar cases and stuff out there. So I think this is probably a better, more viable solution than trying to 3D print an entire custom case, because that's just going to be time consuming and expensive. That's not to say obviously we can't customize these cases or modify them. That would be, you know, fine. But yeah, okay, so all right, that's looking good. So that's got the bits back in. You can really see where it's patchy, and I need to do a respray, but that's be for another day. So the front's got these holes in that you sort of push through. It's also important to note the holes, actually, because I might need to, at some point in a future build, need to get an SD card reader through one of these slots. So that's big enough to fit a card reader through, and then we'll probably need to like sort of hack a hole or something, and then put like a 3D printed bezel or something just over here. That's kind of my thinking. If I do it on this prototype, or if we build a whole new board, because eventually I want to sort of get over to doing a custom PCB with a view of possibly a retail product. I haven't fully made my mind up yet. It very much depends on what the interest is. But really, I'm more. This project is more about getting people interested in building their own machines by sourcing parts themselves, rather than me trying to sell you something, which has kind of always been the ethos with the TinyBASIC computers and now Project Rio. So there we go. How's that looking? What do we reckon? Actually, I'll show you that. Just put the lid on. So it's all metal. Try to get the lid to sit. Come on. Oh, I see. There we go. There we go. So yeah, that's kind of. I think that looks all right. You know, I mean, yeah, it's not going to be everyone's cup of tea. And I need this yellow needs work, but I think I like the contrast and the aesthetics of it. You know, considering it's a sort of off the shelf, generic Chinese made PC case. Yeah, and of course we're all open on the back, so we've got plenty of space. So even though it's a small unit, we've got plenty of space to play with, far more than we did in the 3D print case that I kind of broke up last time. You saw the remnants of being used as a spray test. Anyway, right, so what I want to do is I want to mount the main bits of the system, and here they are. So you can see I've actually taken the chip out from last time. So I've disabled the logic, and all the timers and the diodes and stuff are still in situ, but the chip is the Atmag 328P, which was running the one of the two video terminals, has been removed. Everything else is still in situ. We're now just using the Raspberry Pi. But what I want to do is I want to try and mount this inside this case. Now, it's not going to fit. They are screw mount holes, and you do get a packet of screws. You can get some self-adhesive feet, which is quite nice. But obviously, a Raspberry Pi isn't going to fit in here. So what I thought I might do, just because things will change, and eventually I will look at a better fixing solution, possibly 3D printing an adapter plate, and then a board would fit in that plate. But for now, I had an idea. I'm just going to grab them down here. So I popped into a local store when I was out in town the other day, and I got this double-sided tape and adhesive pads, which are quite thick. And my plan is, although it won't be a permanent solution, but my plan is just for now to hold things in place. Instead of trying to screw boards in and, you know, creating a mess, I thought might just use self-adhesive, sort of the foam pad stuff, to actually fit parts inside, just so we can kind of get stuff basically into the system and working. So let's open up. There we go. So I think these will be all right. I think they're just sort of yeah. So apply, might have to, yeah, might need several just to get past the height of the screws. And that's because we could also fit inside. Let's see how that might work. So, I'm sort of thinking main board, kind of like, no, main board there, Pi, but admittedly heavily modified Pi. So this one in video, which I've yet to release from the original build, this is a Raspberry Pi. This is an original Pi, but I've basically done a lot of work, taken the USB off, taken the composite video off. Just you can see that, and I've hardwired to it. So that's the thing about picking up these original Model Bs. That's all we need. All it's acting is a video terminal and USB drive for a keyboard. So that's all it's doing. It running a bare metal OS. It's not running Linux. So what I want to try and do is, can we get? Is this? So really, I want to try and see if we can fit things sort of like that. But again, it's a tight. Let's lift that up. Yeah, really, that wants to kind of just be a little more over there on top of that screw mount that I don't want to take out. So, I guess if we just rip some of these up. I just wonder if we can just pack some on top of each other. I've got enough of them just to build a bit of height. Super sticky, unfortunately. There we go. And if we just stick that two together, that then creates a bit of height, you see. So if we do that, and I'll take that layer off. There we go. Yes, it's a bit crude. That's three together. Should we take the backing off. I notice that when I'm trying to do something on camera, I do this all the time during recording, because I'll talk and I'll go, oh, I'm trying to take the, and in my head I go, the backing off, but I don't say anything. And I do this over and over again in edits. It's so annoying. You know, I get annoyed with myself, basically, because I'm just like, finish your damn sentences. Okay, so if I just bring that down on camera, so that's now the same height as this fixing here, so that'll work. I just wonder if we can cut that in two. A pair of scissors I have. Other advantage of live streaming directly here from the workshop studio is I've got all my tools and everything is around me, so let's just cut that in half. There we go. Just turn this upside down. So actually putting adhesives on the back of this won't be too much of a problem, because there's no components or resistors or anything on the underside. On the Pi, it's a different story, because it's full of stuff which you can't just stick things to, because I've done that before, and you know, and cause problems with things overheating, voltage regulators, and all sorts of weird and wonderful things underneath an original Pi. So let's just take that off, and we'll stick that in that corner. There we go. And yes, if you can hear budges, yeah, I mentioned this before, the damn things scream and squeak in the night, and you can always hear them in the back of videos. And that's why Project Rio has got its name Rio, from Rio to Budgie. It's not even my pet either. There we go. So again, wish I could say, oh, here's one I had set up earlier, but I didn't, because I'm sort of slightly making this up as we go along. Can you tell? No, I had a rough idea of what I wanted to achieve. It was just making it happen. And this project has changed and morphed around, and you know, all the time there's new ideas or better ways of doing things, or it's kind of availability of stuff. And with the recent chip crisis, which is getting better at the moment, it's not perfect by any stretch of imagination, but we are getting better. You know, components become available or alternatives become available, and you think to yourself, that's a better way of doing something than what I was going to do, including my decision on which chip I'm going to use as the main base for the Project Rio system. So at the moment we're using the AVR Atmel Mega 2560, which is what you get on the Mega board, and I was going to go up to the 1284, which is a dip package chip. Looks a bit like an old Z80 or 6502. It's a proper old school chip. If I got it on my photos, just a moment, see if I've got it. There we are. I knew I had it somewhere. So yeah, so that was the chip I was actually thinking about using. Availability and expense of those is getting a problem, because it's not used in any other kind of, there's no Arduino board. It's very much an industrial microcontroller. It's a nice chip, 16k of RAM, which would have brought system up to 16k color system, which I think would have been very nice. Saying that, because we got SD card support, we can chain things. So in BASIC, you can write a program and you can chain it. So you can load your first, 8K or 6K. And so if you have a 6K splash screen, then you can dump that code, and then part of your game, so it still runs as a program, you could load in the game logic, or you could load in the map. It draws the map, and you can dump the code that drew the map, because that will stay in the screen memory. And then you could load in game logic to play a game, you see. So that's how you used to do it with all the 8-bit systems. So because I'm sort of thinking about that, I'm wondering, is it worth just sticking with the Mega chip, because they are more available. It would run as an 8K system with 6K for BASIC, but you know, it's available. It's a little bit cheaper, and at the moment, that's what all the logics and sort of test code has been built around. So that's my thinking. Let's go back to what we're doing. So I've just made up 2 more of these. So, and no, I don't know if this adhesive is corrosive or anything like that, but it doesn't really matter. Everything's kind of, it's not hugely valuable. It's a prototype, but you know, it's all off the shelf parts at the moment, so it could be rebuilt again. It's not a huge issue, and I'm not going to worry myself about it. So those on there, and now I need to do the same with the pie. And again, the pie is going to be a bit tricky, so you can't sort of just shove it in the corners, and you can't cover up, as I said, all these components and things on this board. You can't, you know, shove a piece of foam on top and go, that's it, I'm done. So, so let's just make up. I might just need the one actually, so I may just stick 2 pads kind of on the board in different places. Again, I stress this is not how we're going to make the final piece, or you know, will everything will be screwed down properly. We wouldn't be using these type of boards anyway in the final, but at the moment this is fine just for prototyping. And you know, I want to get a machine that looks good, so I can take it out to shows in the near future. But also, you know, it's a development piece for writing the software, because there's no point having a computer system if we haven't got any software. I'm hoping people will just write stuff in BASIC for it, but they probably won't. So we'll need some interesting demos and projects. And that's kind of what I'm thinking with this, because it's never going to have a critical mass software ecosystem. It's going to be a niche hobby computer. And this is sticking to me. It's going to be a niche hobby computer, so it's never going to have the sort of mass appeal of a Commodore 64, for example, and that's not what I'm trying to go for. So see it more as a kind of, it's more about people building their computers for themselves, which is kind of the whole point of the TinyBASIC project. And kind of like, you know, those electronics kits, or those like old chemistry set kits that I used to be able to get back in my day. Probably too dangerous now. Basically, kind of bit like that, where it's about the fun of the build, and then you write the code and you get it to do stuff, and you know, that's still really exciting. And someone gets, even with the Raspberry Pi on its own, you lose. You don't get that with the Pi as it's presented normally. So that's kind of why we're doing this. Plus the fact it's just nice in 2023 to build a genuine modern 8-bit computer that's not trying to emulate or pretend to be something else. Right, so we've got a couple of blank areas here, which we could stick. Stick a pad there. And I guess we could stick one. It's a blank area here, which we could stick a pad in. Okay, so we've got the foam feet fitted, 4 on the Arduino setup, 2 on the Pi setup. I'm not going to worry about anything else right now, so let's see if we can get stuff to sort of fit. This is going to be a bit tricky because it's all still wired together, and I'm not madly keen on unwiring it at the minute. So you can let's get that in view. There we are, so you can see it. Right then, so we'll take the adhesive off. And yes, this could be a little bit wobbly, but it'll be all right. It'll hold. Okay. Right. So will you, if we do this very carefully, fit sort of there, just right on the edge of the board. Yeah. Okay. So there's a little bit of play in it, but obviously, it's sitting on 4 layers of sponge. So what would you expect? But that's okay. That's in. That's great. Okay. Let's take that out of the way. So now we just have to do the same with the Pi. The only issue is trying to get access to the SD card is going to be a bit of a pain. I can see that being problematic, but let's just see how the best we do. So all we want to do with this is really get the HDMI facing outwards. And I wonder if I can just get this sort of... kind of like that. That's not great. Let's just take that up. I can't. It's going to rock a bit, isn't it? Might need to just put another pad on. But a lot of this is just about trial and error, Some things work, some things don't. When you watch the pre-record videos that I do, a lot of the time, they're edited, not to hide mistakes as such, but they're edited to kind of, so something is achieved and it looks relatively easy. When you're doing it live, like I am right now, obviously, if it goes wrong, it goes wrong, doesn't it? Plus, if we do it in real time, you kind of get I think you get a better idea of just how long things take to make and do. And we've been on this 3 years now. We've come a long way in 3 years. Don't get me wrong, but yeah, been about 3 years. So there we are. That's another pad made up. So I'm just going to try and put another pad under. A little bit fiddly, and I'm making a ton of mess. Little bits of paper everywhere. So okay. Over there. So there's some space just under there. And that one needs to sit back on there. Okay, let's try that again. That's better. It's not perfect, but that's better. And I think there's enough play to get the SD card in and out, which is great. So, okay, that's in. And oh, you're kidding! I've just stuck me Have I managed to do that? I've stuck that down onto the damn cables. Right. So it's always going to have a bit of a wobble in it, but it'll hold. You can wobble the case, and that's going to hold. And it also gives you the idea of just how much space we've got to play with now, which is great. So at the moment on this prototype, SD cards at the back. What I am thinking about doing is I'd like to try and plug in. See this barrel connector? I'd like to plug in via the barrel, which I think would probably make sense. So that can take. It's not 12 volt compliant. So I did try to put a 12 volt power supply in, and that was a mistake. I blew up the voltage regulator on not this board, but there's another one that's got a tape. I had to put tape over the barrel just to remind myself not to plug anything into it, because the voltage regulator blew up and smoked. Luckily the rest of the board was fine, but yeah, so I think it's 9 volts, 9 volt maximum. So we could just put 9 volt barrels straight into there. And then obviously we've got the ability, or will have the ability, for composite, which I'm thinking will sort of need to float kind of like that or something. So there'll be like a panel put in here. The USB, Now USB will need to come to very shortly, and I'm just thinking to myself now, do I regret? Hang on. There's a second pin header here, so do I need to take this board back out to solder to it? Probably should have done that as well. Yeah. So basically, there's on a Model B, original Model B, there's two USB sockets, and I took those off, and then you get basically a set of 8 holes in the board, and 4 per USB. So it means you can wire your own separate USB in, which is exactly what I have done here. That's what we were using. Now what I'd like to do is forward these to show there these existing USBs in the front of the machine, or at least one of them live. So basically you put your keyboard in there and then you can use the unit. So I guess we need to make another piece of ribbon, don't we? Which might mean I need to lift this board out, which I've just stuck it. Just stuck the board in. Need to lift it back out. Unless no, I really want to keep that one intact, and I just want to build like an adapter board, which we might be able to do tonight. We'll see. I want to build like a little adapter board to break out, and then I can plug in at least one of the USBs, which is here. So I want to plug basically something from there into one of those, and then that'll make one of these live. So we've got one internal USB and one external. That's the plan. I've got bits coming out as well, left, right and centre. So that is a ground that's come out for the composite. Yeah. It's got mess everywhere. But I hope it gives you some idea of roughly what I'm intending to do with this. Right. I think what I need to do now is I need to just go and get another cup of tea. We've just gone 9 o'clock, 7 minutes past 9 here in the UK. I'm going to go and just grab another cup of tea. Check on everything else in the house. So 5-minute tea break, and then I guess I'll be back. So yeah, I'll see you very shortly. And I'm back. Got scoffing cookies as well. I should have had tea. I didn't have tea before I came on the stream, which I think was a huge mistake. Because now, as well as tea break, I'm hungry. Thanks for all of you that have stuck around while I went away. I know looking at a holding card for 5-10 minutes isn't exactly very exciting. So thank you for all of you that have stuck around. I just realised I probably should have used that opportunity to go and get the soldering iron, which I didn't do. That was clever. Right, I'll tell you what we will do though, which I was looking at earlier. So, there is method in the madness, by the way. So this will be mounted sort of in there, as I explained. Now, I talked about these existing jumpers that you get from the faceplate of the machine and how we can actually use these. But especially, we can use the power and the LED indicators, which are really nicely marked as power switch, HDD LED, power LED plus and minus. Now we can actually just interface these straight into our TinyBASIC board onto the header. That was something I designed when I built this original prototype. So what I thought might be nice is we can't use the power button in the traditional PC way. So how this is meant to work is you're meant to press the button and that turns the computer on. That's not going to happen. The minute you put power in the back of the machine, it's going to boot up. and that's just going to be how it works for us. Basically, the way these push buttons work on PCs is they already have like a microcontroller. So when you put voltage through, the PC's technically on, even if it doesn't look on. And it detects this being pulled to ground, or usually pulled to ground, but sometimes pulled high to 5 volts when you press it. And that in turn then boots the main machine up. Well, we don't have that logic on this system. We could do it, but it's a lot of faff just for a power button. So what I thought we might use instead is we do need a reset button. And a reset button, there's one here actually just on the main Arduino board, is just literally a push button that makes, so that's contact, release, yeah. So we can very easily wire this to work as a reset button for the computer itself. So to do that, we've got here power switch, and it's a jumper, it's a sort of jumper, 2 pins connected permanently together, molded together. And what we need to do is we need to attach one side to ground. So I've got some pin header here, and there's already a jumper which I put in earlier to ground. So one side will go to ground, and the other side, which is this green cable, which is already in the board, connects to, there's a pin here which is the reset vector pin, and it's actually broken out onto the header board here of the Arduino. So if I do that and connect both sides to the power switch, now when I press that power switch, it's going to be the same as resetting here. So that's now working as an active reset switch, which is quite cool. So we've just popped that down there. Now the LEDs itself, power LED, we can also use. So you don't really want to put much more than 3.3 volts through, and you do need something like a 1K resistor. So I do have 3.3 volts of the voltage regulator of this board running through a 1K resistor. And I'm trying to remember which one that is. It's one of these top headers, and I think it's, so let's just find power LED plus. I think it's going to go, oops, if I can get this to work. Power LED will go there. That's my 3.3 volts, which is permanently attached to a 1K 1000 ohm resistor, which is just, I don't know if you can actually make that out. It's hiding just there on the board. And then we just need to ground the other side of the LED, which we can do. And then there's one final ground, which is used for the video circuit, which goes on like that. There we go. So the power LED and the actual power switch should now be wired into the system. So we could go for a test and just see how well that works. Let's have a look now. Although it'll be a little bit under voltage, or under ampage rather, we could use an iPhone charger and just go in via the USB socket. I'll just get that out. There we go. So iPhone charger into the mains, USB or USB-B, and that can go into the USB hiding. There we go, just there. It's not ideal this, but it will work. So just a final check to make sure that nothing is grounding. By the way, if you're wondering about the actual metal base of this case, I did test this earlier, but I'll just prove something to you. If I get my multimeter out, and we've got it in continuity mode, which means that when the 2 pins touch, the meter will beep. And if you try and put that across the base, although it is metal, it's been treated, it's been painted, so it doesn't actually conduct. In fact, none of this case actually conducts, although obviously it's not good to have exposed metal contacts sitting on a metal surface, because, you know, sod's law, or you never know. Or let's say, I don't know, hypothetically this got cold or damp or something and it got condensation build up, that would cause tracking or shorting across the metal surfaces, which you don't have to be a genius to figure out you don't really want. So anyway, so that's fine. So we can just check everything is okay, and I guess we could go for a test power up. There we are. Give it a moment. There's the beep tone. Onboard speaker. Or onboard buzzer rather in this case. And the power LED. If I just darken that, so you can see the power LED is actually on. I should just turn on my lights off. Turn both of them off a minute. There we go. So yeah, you can actually now see quite clearly the power LED is on. And if I hit the power button, you see some activity there. It has now reset. There you go. So that now works as a reset. So we can use the existing buttons in the computer itself, which is kind of cool. And we can reuse those. Yeah. So I guess we need to work on the USB interface. Let's turn some lights back on so we can see what we're doing. There we go. Yeah. So USB interface, I guess, next. I need to go and dig the soldering iron out. Tea break, first of all. But yeah, overall, I'm kind of pleased how this is working out. There's a few things I do want to do, and we'll probably do that next time. Main one being I need to take this all apart again to respray, because that is not good. It puts me a bright yellow, and it's no, it's not quite working. Yeah, so I'm just thinking out loud now, which is never good on the stream. Let me go and grab the soldering iron and everything, which I should have prepared earlier, and I didn't. Actually, let me just take some of this paper out of the way. By the way, as I said at the beginning of the stream, anyone wants to say hi or ask a question or comment, it doesn't have to be about what we're doing right here. It can be about anything else we're doing on the channel right now. Or over on Wi-Fi Sheep 2. If you're not going over there, it's 2.wifisheep.co.uk. It's our second channel. I've got a video going live on that very shortly. It's sort of an overflow extra project channel for stuff that doesn't quite work here on the main channel. I've got to be honest with you, I did comprehend actually doing these live streams over on channel 2. Because channel 1, you're never quite sure how people actually take or receive the content you're working on. Right, just bear with me. Find what I did with the soldering iron. I've got a new variable power soldering iron, which I do need to test out at some point. I need to I need to dampen down that sponge as well. Let's just power down. Just take that out. Try and figure out what we're doing. Yeah. Just bear with me. I need to just go and run to the bathroom and just damp this sponge down. There we go. So just a sponge, which you need for the soldering iron. Let's plug the soldering iron and get it up to temperature. Someone on the last stream we did last week asked me about if I was going to demonstrate the running of the system and what you can do with it. And yes, absolutely. It's one thing I have sort of shown bits here and there, but as it's been a very sort of flexible, moving project, it's never quite been the BIOS, well, not the BIOS, the kernel, sorry, and the basic interpreter has never quite been the same from day to day. So I could show something and then how that works, or the command to use it has changed next week, kind of thing. So yeah, I will be showing how that works. We're just heating up the soldering iron right now, and we're going to have a go at tapping some USB in, and I'm just trying to think the best way to do it. I could do it the proper way, or I could do it the really lazy way. Yeah, I also need to be careful when doing this, because if you wire USB backwards, which I have done, you blow up the device or the USB like keyboard or whatever that you're using, and you kind of you plug in, it kind of stops working. Odd that, isn't it? You wouldn't think if you put 5 volts on ground it breaks things, but it does. So I'm just wondering, do I need to make a little breakout board to manage the USB, or do I just be super lazy and grab... I've got a new set of jumper ribbon somewhere. I mean, this is super lazy, and just sort of strip 4 lines of this rainbow lead off, solder sort of directly onto this board, and then just shove the other 4 into the pins of the USB to wire up one of the USBs. Decisions. What do I want to do? Or do I try and put a piece of or do I put a piece of female pin header onto there, so you could just plug and then plug straight? I don't know what to do. Or do you put male header in and then just plug that kind of... You can't see. Hang on. Plug that crudely. Whatever I do is going to be a little bit naff. Right. By the way, yes, you can tell it's live because I'm umming and ahhing because I'm trying to decide what to do. And where's my flux? Got my alcohol-based flux here. Solder is there. I'm going to have to take this Raspberry Pi board up again when I've just stuck the phone down. Yeah, I'm kind of regretting doing the phone. Just take the phone bits off. Oh, God, I might have to redo that in a minute. Yeah, I'm slightly regretting doing that now, but never mind, I did. It is done. Let's take the SD card out just for safety. So basically, if you can see, it says pin header here. It's not quite evenly spaced though, but I might be able to get a piece of pin header in that. And I'm just wondering if I should just, because if I get that the right way around, we should just be able to tap the USB straight in. And you can just sort of clip like that whilst this additional rainbow ribbon lead is in. Of course, you need to make sure you get it the right way around, which I can test. It's not a problem. We've got a multimeter. We can test it with something. Right, let me grab a piece of pin header, see if I've got something that fits. Right, so I bought these packs that go relatively cheap. If one thing I always get through on this channel is the amount of pin header I get through with building and prototyping is just ridiculous. I never ever have enough. I'm constantly breaking it. So I bought this little pack here, and you get sort of a selection of bits. I think I've added some in here, but you get the idea. A selection of bits. So let's just try and do this on camera. So I've got a bit of desk space here, which you can't see on camera. And let's just see what we've got. We've got a piece of pin header I can use. You can always cut some of this stuff up, I guess. Let's just check my other... Where's my other toolbox? I will just cut a piece up if it comes to it, but let's just see if I've already got a pre-cut piece we can just borrow from, as we only need a 4-pin way. I've just got off camera here. There's another toolbox full of pin header. I'm just seeing if I've got a piece that we can scavenge or cut. I'll cut up a piece of that if I have to, but let's just see what we got. See what we got before I go there. Because I'm always hacking it up and then I'm like, oh, I had a piece that did that, or I had a piece that did this, and you end up kind of just cutting everything to bits. And you think, what was the point of that, you know? It's not looking promising, if I'm being brutally honest. No. And as we're live and it's not interesting waiting for me to find bits, let's just cut a piece up. So let's take a smaller piece like that, I guess. Clips or snips, and 1, 2, 3, 4. There we go. That creates the 4 piece that we need. Put this all back in the bag. It's useful stuff to have. You know, I'm always getting through Pinhead. I've just used some of this on another project video, which you'll see shortly on the main Wi-Fi Sheep channel. That's coming up for September. 2 new videos on Wi-Fi Sheep Tech for September, and at least 1 new video over on Wi-Fi Sheep 2. And of course, you've got these live streams, which are extra and additional. Right. Now, because the Raspberry Pi USB header, the 2 inner pins, you probably can't see it on camera, but they're not spaced equally. So what I need to do is just pinch in the 2 inner pins and see if that will fit. Can't see what I'm doing. I mean, don't get me wrong, it doesn't have to fit well, it just has to fit. Nearly. That's not great. Not great, but it's in and it'll probably work. So let's just get that tapped in real quick. So what I like about trying to pick up these original Pi boards is no one particularly wants them, especially used secondhand ones, but they are absolutely great for this kind of prototyping, messing around, pulling apart, and they're cheap and they're big and they've got things like composite, which I know the others have, but they've got a proper composite jack, or, you know, actual solderable areas that you can solderable areas that you can sort of, you know, pull things off, put things on, modify them, cut them up, all sorts of horrible things you can do. Okay, that'll do. That is proper awful. So the question now is, will my USB header even fit in that? I might need to just pull these pins. They're spread apart a little bit, so let's just pull them together a bit. Doesn't have to be pretty, just has to work. So there we go. Excellent. So technically speaking, that is at least one of the USB ports actually plugged in and working. But I need to make sure we've got the connector the right way around, because as I said, excuse me, cup of tea, if you wire it backwards, you'll fry everything you plug in. And I've learnt that the hard way. I should have... Let's just have a look. By the way, all this clutter and toolboxes and stuff you often see in the back of shots is not just for show. I do actually have stuff in these, and one of these, although sod's law, you won't be able to find it now because I don't label anything. One of these somewhere has some spare USB wired sockets. Is that one in the back? No. They're basically, there were USB cables taken off USB hubs. So you've got a standard USB one end, and you just got exposed wires the other. And yeah, just bear with me a minute. I'll just cut you back to that view. Let me just have a quick rummage, because I know I've got them here somewhere. So I saved them for a reason. And this room is absolutely needing, there we go. This room is absolutely needing a complete refit. Especially as I find myself busy doing stuff. So that's what I wanted. So, and this chair is awful as well. Right, so basically it's recovered off an old USB hub. So you've got, I've just got here the red, positive, negative, 5 volts ground, and you've got the actual socket there. So if we plug in like that, and we take our multimeter, again, continuity mode, and we could try if we hold on to ground. And then we need to find something that we know is ground on this. Oops. Okay. So make sure that's connected. Something that we know is ground. That's ground. Excellent. And just to double check, 5 volts. Yep, that's great. So we can use the GPIO pins or any exposed point on the Raspberry Pi itself. So I just wanted to check I have that the right way around, which is fine, I do. So that port there, technically, believe it or not, is now live. That was a lot simpler than I thought it was going to be, actually, and has worked worryingly well. So just let the soldering iron cool down a minute. Oh, we need to try and get this Pi back into place now, which now probably isn't going to be very sticky on these pads anymore. I've just wrenched it off 3 times already. Ugh. Should have thought about the order I was doing stuff in, and I didn't. Oh, hang on, let's put the SD card back in. Full-size SD cards, of course, on these Pis. So you're going to go about. Yeah, I might have to go back and redo that off camera, but it's in. And we've got a little bit of room. That'll be okay. So that can stay as an internal. I want an internal USB at the moment, and there's a very good reason for that. Which, if you looked at my last video where I did RISC OS and talking to nano boards through RISC OS, and it's possible that because we've got a Raspberry Pi running as a terminal, it could have a switch on board. That means we could run 2 kernels or ROMs on the same SD card. So we could run it as the bare metal Pi GFX terminal, which is what it's intended for. But if you, let's say, pull one of these pins low, it could instead boot on a reset. It could boot up into RISC OS, you see. So you could have a sort of a sidecar click and point OS actually on the Pi that then talks to this board. And in order to talk to the board, it will have to do it via USB. So you would have to run a cable sort of from here crudely back in and then through something like a TTL adapter, something like that. So it could actually read. Well, actually, no, we wouldn't. We could literally. What am I talking about? We would need a TTL adapter on one of the other ideas, but for this board, I know what I'm talking about, honestly. On this board, if we've got a separate power supply going in, so we're not using USB, I'll show you this. We could plug that in. So we could plug like that, and then that end would go to the Pi separately. Get that in, come on. So basically you do that. Yeah, you with me? That would be a bit neater. It's a bit crude, but that would then give another connection. So it would mean that these boards could operate and talk to each other quite happily as they're meant to be working now. Or if we ran RISC OS on this, you could actually then run through the, in this case, the CH340 driver. And that would allow you to basically have a serial interface and a click and point GUI interface. So you could then load programs or create new programs in text editor and have a point and click environment. So it kind of almost swaps. This one goes from being the main to the sidecar, and the terminal goes from the sidecar to being the main, so you can actually swap the system over. And that's another sort of reason for why I wanted to use the Pi. Many people are like, oh no, you can't use the Pi. It ruins the idea of the project, blah, 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 blah. But I was like, no, I want to use it, and that's the reason why. Of course, you don't have to use the Raspberry Pi. This system will run quite happily with some of the other terminals, and we will be looking at that. We've also got the build for Project Rio for the ESP32, which I believe I have demonstrated on the previous video. And if you go to our Patreon, you need to join our Patreon for that. It's the £6 tier for Project Rio, and that has all the new downloads and the open source kernel. So you can actually have a look at the C code for the basic interpreter and the OS kernel. So that's at patreon.com/Wi-Fi sheep. Right. I'm just waiting for the soldering iron just to cool down enough so I can move it off the table. I'm thinking we're coming up to, well, where are we? Coming up to quarter to 10. Again, really enjoyable stream tonight. So thanks so much for everyone who has joined and who has stuck around. Really appreciate your company. And of course, those of you that will no doubt pick up this as a pre-record. I know many of you watched it later on. You haven't been able to join me live. But if you can join me live, please do consider it. It's great to have your company. It's great to have a chat. And for those who have contributed tonight, really do appreciate it. So what we'll do is we'll actually see if we can wire this up. And we'll go for a test because I want to test this USB port. So we'll brave a keyboard. It did look like it wired correct, so let's just take that soldering iron out the way. I haven't got a 9-volt supply set up, so what we will do is we'll go in via 5-volt USB power supply into the Raspberry Pi, because there's probably space just to get that in there. It's not ideal at all, but if we can go in via there, we'll go in. There we go. So that will go in like that. Let's get my, where are we? Where's that monitor gone? Oops. So I showed this last week, I bought this composite TFT display which is all right. It's cheap, but it's big enough you can actually see the screen. So we'll just test with that, and we can use. I've got a there we go. RCA composite cable. So let's go from video, which will say white, and we'll go white to yellow, which is kind of like that. We now need a power supply for this. Now we can use a like a laptop brick. DC AC adapter, AC DC adapter, sorry, or rather, and plug that in for the screen. That goes into there. And keyboard. Which keyboard do I want to sacrifice? Good question. I've got this slightly horrible one that will work. So let's pop that there. So I'm going to put the keyboard into this USB socket. There, you can see that. There we go. Right. Pi has moved already. Yeah, it's not massively happy on that, but okay. Good enough. Right. Okay, are we ready? So, power to the monitor. There we go. Display is on. And power the system. Keyboard flashed. I saw it. There we go. That's looking all right. So that's, yep. I'm just seeing where my hashtag key is on this. Well, he says it's all right. The keyboard doesn't appear to work. Now, is that because the keyboard's rubbish, or is that because I've done something? This is why we use keyboards like this. So I don't know. That works. Interestingly, the terminal says it hasn't found the keyboard. Okay, well, we know it's not frying the keyboard, so I'm going to risk it with a slightly better one. I literally have a pile of these mini keyboards just dumped down here, so right. Now I begin to wonder: is this wired the way I think it's wired? So what happens if I pop that into this one, which we know works? Let's just power down, power back up. Yeah, it's found the keyboard. Okay, so that needs a little bit more thinking. It's not fried. It's not fried anything. Oops, take the unlock off. It's like again, hashtag mem, and that gives you the memory reader, which I know you can't probably see because it's quite small, but unless I've just, let's just try. Yeah, let's just try that again. One last test. No, okay. Okay, so I got a little bit of stuff I need to work out what's going on there. Curious, very curious that. Okay. Fundamentally it works, and this is kind of teething at problems stuff you can kind of sort out. I just need to basically get my my USB lead back, clean up these connectors, and just work out where the data. So you got it's not clock and data. It's data plus, data minus, plus and minus on a standard USB. So it's 4 wires on a USB, and I just need to figure out what it's not happy about. It could be that perhaps, I can't remember if the terminal program PyGFX is picky about which USB port you put the keyboard in. I can't remember. I don't think it is. But that's just something we need to work out some other time. Yeah, okay. Well, you know, it's not all bad. It's not all bad. Yeah. Let's just check that reset works. Yeah, so you can see it says rebooting system, so it identifies the reset. There we go. Great. Okay. Well, we're getting there. And this sort of pile of mess, well, I say pile of mess, but it's going to be a lot. Oh. Interesting. Yeah. So obviously with a kind of experimental system like this, there's always stuff that's going to be a bit flaky. And you know, I've literally just, as you saw, tap something in very quickly with solder. And I was hoping that was going to work a bit better than that, but perhaps the pinout isn't quite how I think it works. As I said, I'll need to investigate that a little bit further, which I'll probably do. I suppose we could do it now. Probably going to be on stream for another few minutes, probably another 10 minutes, 15 minutes tops. Don't really want to be on too late. Ironically, probably 10 o'clock be good enough. So let's just clear off the rest of this outer casing. Let's just have a quick look in the chat comments, and it's been good to have. It's been good. Have to watch some of us back. Yeah, well, you absolutely can. You're more than welcome to watch it back. Most people do watch it as a video as opposed to a live stream. With a bespoke keyboard, this project could be worth $500 across the Atlantic. Yeah, I mean, I did think about doing a sort of like a wedge shape type, you know, classic micro look. We did something called the Micro One, which was a project here on the channel a few years ago. Which just used a Raspberry Pi and stuck a off-the-shelf Chinese keyboard in a sort of foam or plastic box. Yeah, I mean, I have thought about that, but I don't know. It's trying to gauge what the hobbyists, people like you, want really, and also trying to get the costs down so we're not, you know, it's not breaking the bank or being so ridiculously expensive. There we go. Okay, so these two here, the white and the green, are actually data lines for USB. So if I pop that in there, I guess let's power this down a minute. Let's just take this plug out. And how are we going to do this? I need another jumper wire. If I just grab something from something. Doesn't have to be amazing. So I just need a single end-to-end cable and plug that in there. Multimeter, continuity mode, beeps again. Hold on there. Interesting. Really? Is that not, that's not wired how I thought it was wired, which makes no sense at all. Really? Hang on. I should get the clips out for this, really. Okay, yeah, that's correct. Is that not working, or have I just not plugged it in right? No way, is that really not working? Or is this wired really weird? Hang on, what am I doing? Nope. Of course, we could just try the other connection. Might be I've got a slightly dodgy cable. I can't believe that's not wired right. Let's just try that in here. Let's try on the other connection. Yeah, I think I've got a dodgy connector, you know. That's unreal if I have. Yeah, I've got it's a dodgy connection of all things. Can you believe it? Right, so and again, being very careful. If that goes on there like that, I just make sure my ground is correct. Yep. So that USB is the correct way around. Just take that out. I'm going to put my other dodgy keyboard back in. Basically stuff I don't care about. And trust me, when you're doing stuff like this, you need burner units, burner chips, burner boards, everything. Just stuff that you don't mind blowing up if you wire something wrong one night. Right. Just found the keyboard. Lasted all of 2 seconds, but it found the keyboard. Yeah, there we go, that works. Apart from it's now doing a strange... Come on. I think we got a loose connector somewhere. Which we had a problem last time with the voltage being... what I'll need to do with this is just for reliability, I will need to hardwire. It's just a reset. I will need to hardwire the mains voltage, the 5 volt TTL logic, to make sure that these two boards are powered properly together. Be less of an issue when we're running off 9 volts through the Arduino as opposed to 5 volts on the Pi. Because obviously, as I've mentioned before, the voltage regulators on the Arduino board will regulate that down to 5 volts. So yeah. Right, so that's an interesting one. So we've got a slight issue with, I mean, I can fix that, but can you believe it? And that's why it didn't work. I thought there's no way that doesn't work, or, you know, what have I done wrong there, kind of thing. Yeah, okay. So we'll power down. So yeah, that's looking really good actually. That's a good night. We've done quite a fair bit there. That's got that working really, really well. Let's just, so we can take this power out. There we go. The board still wants to sit kind of straight like that. That wants to sit in there. I need to get some cable ties just to hold things down. And I'll go kind of like that when we get a back plane in. And let's grab me lid. Which would be like that, and I've got 2 screws. The screws are sort of all really nice for this actually. Even the connectors, but maybe it just needs a dry solder joint on. I'll have to take it apart, and I'll do that off stream, just to check that that plug works or doesn't work. So let's just try and get these in. Don't want to over tighten, but at the same time there we go. So imagine that kind of, I know it's a bit blurred, but imagine that kind of in a plate just above the pie like that. And then this mostly being blanked off, but you put your power through 9 volts through there, and that'll create quite a nice little 8-bit programmable computer system. So yeah, it's coming on. We're getting there. So I'm really, really happy with that actually. Yeah. So I think we might call it a night. I think my tea's gone cold, by the way. I think we might call it a night there. So once again, thank you so much for joining me for this 8 till late live stream right here on youtube.com/Wi-Fi Sheep. If you haven't done so already, please do consider liking and subscribing to the channel. It's my intention to be back same time next week. Do keep across the social media on Twitter /X and Threads and Instagram. It's all at Wi-Fi Sheep. On those platforms, and I'll be posting, also be posting on the main YouTube channel when I'm going to be live, so do make sure you keep up to date with that. Hoping this will be a regular thing actually, so people seem to enjoy. I've really enjoyed doing these streams. Very much enjoy your company. It's really nice to kind of interact with people. Some of you I know, a lot of you I don't know, so it's always great to have your company and a direct company actually in the chat. It's always really nice to interact and talk tech and just enjoy an evening of actually building something and getting something roughly to work without messing it up too much rather. But yeah, so we've got a lot to do. We've still got bits of this project to do. I need to do some improvements to the code kernel. We need to actually plumb this thing in properly to a video capture card so you can see properly on the screen what's going on. I need to run the system and do a basic introduction and coding tutorial. And we need to work with the game controllers and the DB9 D-sub connector and figure out how we're going to wire that in. So that's going to be really interesting. I think we're going to do something where we have the controller when it works, and you just got like moves blocks around the screen of colour. So it's going to be quite simple stuff to start with. But who knows where that'll go. Right, well, I think that's just about it for me for this live stream for tonight. So as I said, once again, thank you so much for your company, and I will see you real soon right here on the channel. Have a great night, and I'll see you again real soon. Good night.